Hello, welcome to another lesson. Before now, we've been doing web-based attacks like SQL injection and cross-site scripting. Now, we are learning command injection, which is one of the most powerful web vulnerabilities. Command injection is when you trick a web application into executing operating system commands on the server. Think of it like this. Imagine you ask a waiter to bring you water, but instead you slip in a note that says, also bring me the keys to the safe. That's basically command injection. Command injection happens when a web application passes user input directly to the operating system shell without proper validation. The application expects you to enter normal data, but you can inject shell commands that get executed on the server. And for this demo, we are going to be using DVWA. So the first thing you need to do is to log into your DVWA and then come to command injection section here. After clicking that, you are going to see a simple form that says ping a device, and you can see enter IP address with a submit button. So this is collecting IP address and then it's going to ping the IP address for us. That means we can try to do a few things. So we can try our local host address and then we click submit. And now you can see that it's pinged the address, right? That is why you are seeing these results. You can see ping 127.0.0.1 and you are seeing the bytes of data here. Also, you are seeing 64 bytes and other information here. This is a normal behavior because the server is running the ping command and then showing the output. But if the application doesn't validate our inputs, that means we can inject additional commands, right? Yeah. In Linux, we can change commands using special characters. We can use semicolon. Semicolon tells the shell to run this command, then run the next command. Also, we can use double ampersand, and this tells the shell to run this command, and if it succeeds, then run the next command. And we also have the pipe symbol, which passes output from one command to another. Now, let's inject our first command. Let's say we want to type the localhost address, which is 127.0.0.1, and we are chaining another command to it. So we are going to use a semicolon and we want to run who am I. Who am I will give us the username of the system that we are using. And now you can see that it's run that command and then it's run this too. Can you see this is www data and that is the name of the user. Also, we can do more. We can come here and say 127.0.0.1. Then we chain another command to it and we say ls. That means we want to list what is in that current directory. And after that, you can see that it has listed all the files or folders inside that directory for us. You can see help, you can see index.php, and you can see source. That is if you want to see the files from the directory above. That is the directory before the directory we are currently in. What can we do? We can do that by using ls dot dot. So what we can do is to type 127.0.0.1. Then we are going to type ls and attach these two dots there. You can see that it is giving us all the folders and files in the directory above. Another thing we can do is to output or dump all user accounts that exist on this Linux system. And how can we do that? We can use 127.0.0.1. Then we use colon and we type cat. Then we say etc. You add a forward slash before then another forward slash after etc. Then you type pass wd. And once you run this, you are going to see all of the user accounts starting from root. You can see root, daemon, bin. Every user on the Linux system would be dumped to us. You can see everything here. And this is very dangerous. Also, what if you want to know the current directory that we are in? So we can chain pwd to that. Some people call it present working directory. Some call it print working directory. So we can say 127.0.0.1, then we chain pwd to it. Then we can submit this. And the moment we did that, you can see that it is showing me my current working directory, www, html, dvwa vulnerabilities, and exec. This is the directory I'm currently in. Also, you can use it to view the date. You can do 127. You can type 127.0.0 dot one, then we can add date to it, and it's going to output the date for us. And now you can see the dates here. Another thing we can do is to discover the operating system the server is running on. And this is very serious as well. So, and for us to do that, we type 127.0.0.1, then we type uname, then -a. And the moment we do that, you are going to see the name of the operating system here. You can see the details here, including the version. You can see Kali version 6.7.10. You can see it here too. The next serious thing that normally shouldn't happen is this one that we want to do, and that is dumping the content of the environment variables. Environment variable file is something very sensitive, and it shouldn't be accessed by anybody. It can contain the password to some systems or to some downstream services, so you need to protect it very well. And now let's try to dump the contents of such a file. So we can type 127.0.0.1, then we type env, and we can submit this. And now you can see everything here. So it's going to have something like key and then the value of it. You can see Apache run group, then www data invocation. You can see the value here. Apache log directory. You can see the value here. And this is very dangerous because in some systems, maybe web applications, this is what it is going to look like as well, but it's going to be containing some serious details. So it is not something we can afford to show to just anybody. What if we now want to check the disk space on our system? We can type 127.0.0.1, then we add a semicolon, and then we have df, then -h. So then we can submit this. And now you can see everything here. You can see file system, the size, the used parts, the available parts, and where it is mounted on. You can see the dev/SDA1. You can see that that's 79 gigabyte, used 39 gigabyte, available 36 gigabytes. The used percentage is 53%, and you can see it for others too. So this is showing the disk usage. That is the file system sizes, the use space, the available space, and the mount points. As I said, this is very serious because attackers can use this to see if there's a space to upload malware. The next thing we want to do is to see what processes are running. And this is another dangerous thing because they can kill some processes for you. So we can type 127.0.0.1, then we have ps and aux. And when you run this, you are going to see all of the processes that are running. Can you see them? So if an attacker can see this, they can know what to kill or what to stop. And I won't lie to you, this is a valuable finding for more attack vectors. Next thing we want to do is to display a custom message. Let's say we want to display something like this system has been hacked by Victor. So we can just type 127.0.0.1 and then we echo. Then we have this system has been hacked by Victor. And yeah, we submit and boom, you are seeing that here. So it is concatenating or adding the result of pinging 127.0.0.1 to this system has been hacked by Victor. Now that we have been able to use the semicolon very well, we can proceed to use the ampersand too. If you want to use the ampersand, then you know that the first one must run and the second one would then run. So it is just like a logic gate. It's like an AND gate. So we can say 127.0.0.1, then we add the two ampersands, which is and we can type who am I. For this, who am I will only run if this one works. That is, if you're able to ping this, that is when who am I would run. So we can try to submit this, and you'll see that it will give us similar results to that of when we were using semicolon. Another thing is that if we want to run a command in the background, we can use a single ampersand. So what we can do is to come here and type 127.0.0.1, then we type a single ampersand, and then we type who am I, then we submit this. And that will run in the background. And you can see that the moment this is running, you can see who am I here, then this now continues, right? Then followed by this. Now let's try to use pipe. So we can say 127.0.0.1, and then we use our pipe, which could be, we can use it with this. So pipe means or, so it means that you are either running this or running this. So we can run that, and you can see that it is only giving us the contents of the passwd file. You might be wondering why this vulnerability. If you come to view source code here, you can see what is happening here. So what they are doing here is that they are determining the operating system and then execute the ping. So they are checking if it is for Windows. So if it is for Windows, then you are going to run ping. And then if it is, they are using else, which means that if it is Linux and they are using else, that is if it is not Windows, maybe if it is Linux, then you should run ping C for command. And what this means is that when we enter 127.0.0.1, it runs ping C for 127.0.0.1, which is a normal behavior. But when we enter 127.0.0.1 and we're adding a semicolon followed by who am I, it runs ping C for 127.0.0.1 followed by who am I. And what is happening here is that the shell sees the semicolon and executes the two commands. This means the application is not validating our input, it just accepted our malicious command and passed it straight to the system shell. So what's the fix? To fix this, we can use something like this. And here you can see that we are validating the IP address. You can see that we are validating the IP address format, and we are escaping special characters so that they can't be used to inject commands. Better yet, another solution is that we don't use system commands at all. We can use PHP functions or libraries that don't involve the shell. The lesson in this demo is that never trust user input. If you must execute system commands, then you must validate the input format strictly. If possible, you can even avoid using system commands totally. You can use programming language functions instead. If you must use system commands, then use escape shell arg, just the way I wrote it here. Another one you can use is escape shell command. Another one you can use is escape shell cmd, and this can be found in PHP. Careful of. Now let's consider our assignment for this lesson. So what you're going to do for the assignment is that you're going to execute these command injections on your DVWA low security. You can see them here. Also, you can use semicolon, double ampersand, simple, single ampersand, and you can use pipe as well. And once you're done with that, you can share your result with our community. This is the link to the community here. It is going to be added to the description of this video as well. It is added to the description of this video as well. And here is the challenge, and for this you just need to drop the comment, and for this you just need to answer it in the comment section of this video. Explain why command injection is more dangerous than SQL injection or XXX. What could an attacker do with command injection that they couldn't do with the other web vulnerabilities? Also, you can give a real-world attack scenario where command injection leads to complete server takeover, including exact commands an attacker might use to establish persistence. So that's all for this lesson. If you're here to subscribe to our YouTube channel, please do that now. Also, do not forget to like, share, and comment. Thank you, and see you in the next lesson.